Awesome. What's up, everybody? My name is Kyle Gallatin. I am a machine learning platform engineer at Etsy, and I'm here to talk about machine learning in production. Whew, out of breath from that juggling attempt. I also just want to thank everyone for welcoming me here. Came in from New York, and I just want to say that Tel Aviv is one of the coolest tech scenes of any place I've been. I was here less than 3 hours before I was talking about my favorite way to develop locally on Kubernetes with somebody, and that's a really cool experience. So I'm going to start by talking about Etsy a little bit as a company, talk about machine learning at Etsy, how my team specifically enables machine learning across the Etsy organization, and then finally dive into some of the technical specifics of our ML platform itself, some of the redesigns we've done, and some of the success and challenges that we've had there. So Etsy is an e-commerce company for people who don't know it that well. It's basically a company committed to using business and technology to strengthen communities and empower people. Basically what that means is we sell stuff. So we have 88.1 million active buyers, 5.3 million sellers, and 100 million unique items. Most of these are handmade, very, very individualized things that people sell and buy on our platform. What this means for machine learning at Etsy is that we have a lot to do with search, recommendations, ads, and trust and safety. So last Black Friday, a big year for purchasing, our ML platform and systems at Etsy handled over 280,000 requests a second. This is just the machine learning platform. And processed over 11 gigabytes a second of feature data in real time. So our systems have to scale quite a bit to support the amount of machine learning that we do in real time to provide searches, recommendations, and ads to our users. My group specifically is called MIPS, which is the Machine Learning Infrastructure Platform and Systems team. And our goal is to enable machine learning across Etsy. We're a central group that provides services to internal customers who are machine learning practitioners. Where we sit is all the way down here. So we're what's called an enablement group at Etsy. We have core infrastructure, enablement, and then all the way up to places like search and ads who use our services to deploy machine learning at scale, train models at scale, and deliver all of these things in real time to actual Etsy application users. These are all the different squads in our team. We have a feature systems team, a streaming platform team, a bunch of other teams that don't really matter right now. But I'm going to talk mostly about model serving and training and prototyping. So I'm an engineer on the model serving team, so this is real-time machine learning serving. And both of these groups are in what's called the machine learning platform team at Etsy. So let's talk about Etsy's machine learning platform. I wanted to breeze through the high-level stuff. I know y'all care way more about the actual technology that powers our platform than what I do. So Etsy's machine learning platform is composed of two groups. Like I said, the model serving team and the training and prototyping team. On top of that sit all of the actual machine learning practitioner teams at Etsy. So I feel like Etsy's a cool business in that machine learning is very, very related to our bottom line. Things like searches and ads are really, really directly tied to revenue and profit, and we can experimentally measure that. As a result, we put a lot of investment into our machine learning services, platform, and processes. I want to start with our training and prototyping workflow for a typical data scientist or machine learning practitioner, and talk about how we actually redesign this process to serve them better. So this is what our machine learning platform looked like 2 or 3 years ago. Folks would do kind of ad hoc prototyping in Jupyter notebooks. They would write their data processing pipelines in PySpark or Scala Spark, and then they would run ad hoc training jobs on Kubernetes to train their models. All of these tools were kind of supported in-house from an infrastructure perspective, and were kind of confusing to work with. It took a long time for essentially a new ML practitioner at Etsy to write a new model, train a new model using our in-house frameworks, write PySpark code for data processing, and then actually bring that model to production. So what we wanted to do is use more cloud native and open source services to enable them to deliver faster and better after having joined the company more recently. So for prototyping, we moved from just kind of individual ad hoc notebooks to Vertex managed notebooks. We're at Etsy completely on Google Cloud. We use a lot of their, pretty much exclusively use their infrastructure. And we've been leveraging more and more of Google's out-of-the-box machine learning services to help deliver value quickly. So Vertex Notebooks has enabled us to, enabled our machine learning practitioners more specifically to run ad hoc machine learning jobs on whatever infrastructure they want. So they can attach notebooks to CPUs, GPUs of different sizes, high memory machines, all that kind of stuff, to just get the infrastructure they need to train and test models and iterate as quickly as possible. For data processing, we moved from PySpark to Dataflow. So Dataflow is essentially Google's cloud Beam as a service thing. It's based on Apache Beam. And kind of like Vertex Notebooks, it's enabled us to be really, really Python native and first. The Beam SDK has a Python version. Data scientists and ML engineers are all terrible engineers, which is why we write Python. And it really helps us to have a lot of Python first things in this workflow to help our engineers deliver as quickly as possible. Finally, for model training, we've moved from Kubernetes to Vertex custom jobs. So Vertex, again, has a lot of machine learning specific support. I personally love Kubernetes, but for model training, it was sort of difficult for our data scientists and ML engineers to work with. And moving again to a more cloud native service provided by Google has helped unblock our engineers and train more models faster. Yep. When it comes to actually moving to production, so let's say that I'm an ML engineer, I've prototyped my model, I've got all my pipelines set up in notebooks, but now I want to actually orchestrate this. We at Etsy typically retrain models on like a 24-hour basis at this time, automatically, based on a sliding window of data. So we want is to automate this via some DAG. Some folks use Airflow, but what we've been moving towards is Vertex pipelines, or Kubeflow, Google's managed service again. So here's what a typical process would look like for a data scientist. They might prototype some models in Jupyter on Vertex. Once they have that going, they would set up a DAG that does data processing and data flow, model training on Vertex AI, and then here's where we add some of the really cool ad hoc testing to our services. So once they've actually trained a model, we have Kubeflow components that help automatically deploy that model to a essentially test service in dev and run automated load testing. All of our current services use gRPC, and GHZ is a cool open source framework for running load tests against gRPC services. So model server comes up, we run an automatic load test, and then we use Python code to generate a latency profile. As we move towards more deep learning based models, one of the huge bottlenecks for us has been latency. We typically want to serve models in under 100 milliseconds or serve individual inference requests. And so we try and weed out as early as possible if someone's trained a model that's too heavy or is too computationally intensive to be served efficiently on our platform. So it doesn't matter how accurate the model is if we can't get predictions to a customer in a reasonable amount of time. So we add as much automation and tests as possible to ensure that a model is ready for production and ready to actually move to our model serving platform. So here's what our model serving platform looks like. Data scientists and ML engineers will train artifacts and either put them on GCS or on an NFS drive, basically, where they can be mounted to any number of containers that we deploy in Kubernetes. So we have an in-house model management service. It's essentially just a Python wrapper over the Kubernetes API and a UI, but it allows data scientists and ML engineers who don't know Kubernetes to create scalable deployments themselves without touching any of the infrastructure. So they can come through here, and either via API requests or via a nice little self-service UI, they can create scalable deployments using TensorFlow, any Python-based code they want, or a deprecated in-house framework. All of this runs on Kubernetes, and more specifically on Google Kubernetes Engine, which is great. So upstream client applications can send requests to any one of these model services using REST, or more currently using gRPC. One of the big switches that we made in our new platform is moving almost all of our internal services to gRPC, which has given some great latency and performance benefits, especially with really large ML serving model payloads, which can be like megabytes in size. So sending those as serialized protocol buffers as opposed to serialized JSON has been beneficial for us in terms of payload size. So some of the positive outcomes of this redesign. Using open source suites like TensorFlow and Seldon and all these Google managed infrastructure has enabled us to use a lot of services right off the shelf. So as opposed to building a lot of stuff, accruing a lot of in-house tech debt, we can rely more on documentation and open source things to help speed up our workflow and not get bogged down by support and maintenance of a lot of internal code that goes stale. Using things like Vertex custom jobs instead of in-house tools has enabled a bunch of ML experiments per quarter. Really rapidly sped up our development cycle. Some teams can deliver twice as many experiments. One team ran 2,000 ML experiments like in the first quarter of 2021 on the new platform, which was great. And one of the biggest things, we've seen really huge product wins for moving towards a lot of TensorFlow and Google-based deep learning models. So all of the performance benefits, including the performance benefits from gRPC in these models, have led to large increases in revenue for deep learning, more intelligent models that we're deploying to production. But of course, none of this would be complete without all of the failures that we've had. There's definitely a lot that went well, and there's plenty of things that we needed to improve. So this is kind of a classic build buy, right? But moving from in-house to open source and managed services gives us a lot less control. When we were working with in-house frameworks, especially our in-house Python framework, we could add any debugging code we want, logs, metrics, anything that we could write in code. We could isolate, debug, add distributed tracing to, and improve performance. Now we're using TensorFlow serving. Again, machine learning engineers aren't great engineers. I don't have time to learn C++ and get into the weeds of this service. Neither does anyone on my team or the individual data scientists. So we rely a lot on Google's help to try and debug things if we have high request latency or receiving errors that we can't get. And if these logs, metrics, or tracings not available in any of these open source or managed tools, then it can be difficult for us to kind of go in, isolate the problem, and improve on it from there, especially if it's something that's blocking latency or is hard to work with. So that's been a huge area and bottleneck for us. I would also say that new platform technologies like gRPC have a pretty steep learning curve. Is anyone using gRPC for their services right now? Yeah, do you like it? Do you hate it? Yeah, it's way harder than HTTP, right? It's like, I mean, it's always going to be a trade-off, right? Like, yes, it's going to be a little bit faster, but only if you can actually develop it and get something out there. So definitely learn that gRPC is more performant, but way worse DevX, and that can lead to really, really slow iteration. The framework is way less documented than REST. It's much harder to find examples of things that you want to build or work on. The community for gRPC is fairly small and growing. Like, you're not going to find the answer to your question on Stack Overflow. You're probably going to find it like in the 100th comment of like a GitHub issue. It's going to be the worst. And finally, it just has a steep learning curve in general. It's really good for service-to-service communication, but not good for people-to-service communication. You can't test these services via browser. It's a little bit more kind of abstracted what's going on, and it can be really difficult to debug these services without knowing the in-depth details of how gRPC works and how protobufs work. Finally, we've had challenges around adoption and migration. At the time, like right now, we still have 50 real-time models in production that are using our old model serving framework. So this is an in-house Python framework. And we need to migrate all 50 of those models to our new service. And that comes with key challenges. Like migrating to new tools for our ML practitioner teams isn't the top of their list. They want to get a new model, a new experiment. They don't want to be bogged down writing migration code just so we can deprecate an old system. And they have to run experiments to do that. If it's not a simple lift and shift, we have to actually run an online experiment with real traffic to prove that moving to a new service doesn't actually degrade the model performance or result in less clicks, metrics, or revenue. And so until then, our team is spread increasingly thin, trying to support all of these additional code bases and all of these additional frameworks. So we've been trying to troubleshoot all of these things by essentially being a good partner team. We're trying to add more documentation and decrease the amount of time it takes to migrate, but all of these things were things that during our platform redesign, I would say we almost underestimated as issues, and have since worked to build better systems around. But same thing with anything. Oh, that was the last slide. Anyways, yeah, thank you. Again, I want to thank everyone for having me here. This is a super awesome conference. Tel Aviv is great. We have a Code as Crafts blog where I have an in-depth article about our platform redesign, talking about the technologies we chose and why we chose them. Etsy's always hiring, remote jobs as well. And again, thank you so much for having me. It's been great.